Choose a substance that is a salt. Choose by choosing A, B, C, or D. This substance is not a salt because this is not a metal symbol. A salt is an ionic compound, and you have to know this in your head. You have to know the definition of the salt. Salt is an ionic compound that is not an oxide or a hydroxide. So this actually, all this has chlorine at the very end here. So I'm not giving you any hydroxide, or I'm not giving you any oxide, or I'm not giving you any acids. So then you say, well, this is a covalent compound, so it cannot be a salt. This is a covalent compound, it cannot be a salt. This is a covalent compound, it cannot be a salt. This is an ionic compound because Sn is a metal symbol. So to me, it should take you 1 minute or less to figure this out. You have to have that definition of salt in your head. And once you have that, it's just a question of saying, okay, this is what it is. All right, number 2. Choose the substance that is a strong electrolyte. Once again, you need to have the definition of strong electrolyte in your head. Now, once in a while, you may not have a definition in your head, or you need to refer to it. You should know how to go, where to go and get this definition right away. That is the next thing. Suppose you don't have that definition in your head, not clear enough or whatever, then you need to know where to go in your guidebook and find that definition. It is there. So it's a question of you knowing how to go there quickly. Or it's a question of you writing it down, write down 2 pages of notes. The important stuff that you think might be in the exam, write them down, have them in the front of you. A piece of paper, 2 pieces of paper, 3 pieces of paper, I don't care. I mean, I have given you permission. That's okay to do. What is not okay to do is to not have somebody else tell you what to do. That is not okay. And if I see that, and I can see that, I have seen that, I was suspicious. This time I did not bother with it. But there are some if I see that, I will go to the dean directly and I'll raise that question with the dean. And I say, these 2 students or whatever seem to be doing their dishonesty as far as education is concerned. What are we going to do about it? And then we'll talk about it and then figure it out and deal with it. So I am telling you, I am on it. So please don't do that. Don't have 2, 3, 4 people conspiring to take an exam. That will not work. That will be problems. Not just that could be problems because I will find out, but because that will be problem if you don't know chemistry 1A and you're going to go into chemistry 1B. Forget it. Chemistry 1B is going to take more time. It's going to require more understanding than chemistry 1A. I am preparing you for that. It's my responsibility to make sure that you understand chemistry 1A enough to go into chemistry 1B and be able to deal with it. And longer term, almost all of you are going to go to the university. It's my responsibility that when you go to the university, you are not totally afraid of the university. You are not concerned, oh, I don't know what to do. You are not going to fail there. That is my responsibility. Even today, even when you are going to the university, you were my student, so it is my responsibility that you are able to deal with that situation. There, the teachers are not, you won't be able to go to the teachers with problems. Like, there are some people who would be helping you with that, definitely. There are some coordinators and stuff. At the same time, it's not going to be like that. And when you're taking the exam, 30 minutes is 30 minutes. Whatever the quiz and whatever the exam is, there is no change. Nobody's going to say, oh, too bad. Or nobody's going to say, oh, you cannot say to anybody, oh, the exam was too long, or perhaps you might be able to say it, but nothing is going to be done about it because that is what is expected of you. I'm trying to tell you what is expected of you. And that's why this is what I am wanting you to do. That's why here I will guide you. So take my guide and go into it. Okay. Question 2, choose the substance that is a strong electrolyte. You need to know the definition of strong electrolyte. And if you don't know it, as I said earlier, you should right away should be able to go where that definition is. And maybe you want to write down, the 3 units that you are doing for the quiz. You can write down this unit has this and this in it. These are the little topics in the unit. These are the little topics in that unit. And then you can go to that unit right away and read it and quickly answer the question. That will take 2 minutes at the most, maybe. And the third thing, as I told you, is that you're going to write down the important things on 2 pieces of paper, print it out, small print, so you have a lot of stuff on it. Make sure you have headings so that you can go right into that. That's all right to do, I'm telling you. So take advantage of that. So then you do that. Substance is a strong electrolyte. A strong electrolyte has to have ions in them. We talked about this in the lab. It has to have moving ions. And most of you were able to answer that question. So moving ions, is this an ionic compound? No, it's not an ionic compound. It doesn't have ions. So forget about moving ions. Is this an ionic compound? Yes, it is. Sodium is a metal. It's a symbol of a sodium in the front. It's an ionic compound. You don't care what that negative ion looks like, but it's an ionic compound and it's aqueous. There you go. You don't need to go C and D. This is the answer. This is a strong electrolyte. Now, for the sake of it, you would go over here. You say, this is a covalent compound. It looks like there is a hydroxide ion there, but this is not an ionic compound. This is a covalent compound. So this is not electrolyte. And the last one is a solid. And there were at least 2 students who gave me this as an answer. Solid. A solid does not have separated ions. The ions cannot move in solid. Electrolyte, the ions have to move. Okay, question 3. So this would take maybe 2 minutes. I would say 1 minute, but if suppose you don't know the definition of electrolyte, you need to find that. You should know how to find it quickly enough. Okay. Number 3, choose the formula that is both an empirical formula and a molecular formula. What is an empirical formula? Again, you need to know the definition. These definitions you need to know. You have to have them in your head. And if you don't have them in your head, you should know how to get to them very quickly. So an empirical formula is the simplest formula. Well, there it is. This is the simplest formula. You cannot simplify this further. You cannot divide this by anything but by 1. So this is simplest formula. That's it. This is not a simplest formula. You can divide this formula by 2. This is not a simplest formula. You can divide it by 2. C2H4O2. So that's you can divide by 2. So this is not a simplest formula. This is not a simplest formula. You can divide it by 2. So this one is the simplest formula. So that is the both empirical formula and molecular formula. These are only molecular formula. These are molecular formula. They are not empirical formula. Okay. Number 4, what is the coefficient for oxygen in the following skeletal equation? Balancing equations. And 8 carbon here, so 8 over here. 16 hydrogen here, so 8 H2O over here. That's very simple. And then most of you guys got it. And then you have how many oxygen here, and so just take a number over there and write it down, and that's that. Should not take more than a minute. Really, this is what we expect from chemistry 1 students. And I already told you why we expect these things. Okay, number 5. Calculate the percent of water in sodium sulfate dihydrate. A number of you still do not know how to write a formula. This is sad. It's sad. 3 or 4 people did not know how to write a formula. Many, actually, more than that. Sodium sulfate dihydrate. All right, you don't know how to write a formula, then you should know where to go to learn to do that quickly. And you should be able to do that quickly because we have done the homework. So the homework was made so that you have practice enough so that you can do this. So you will go to the last page before the last page, and you look And it says right at the bottom of the guidebook page, it says hydrate. And so you say, okay, there it is go. So sodium, what is the charge on sodium? 1+, nobody should have to tell you that by now. Sulfate, there were 2 or 3 students who did not know the formula of sulfate anion. This is sad. Simply said, we have been talking about this for a long time. From the second day, I said, you got to have this memorized. And if you don't have it memorized by now, at least go to the last page and look it up. It doesn't take much time. And then sodium has 1+ charge, sulfate has 2 negative charge. You're gonna need 2 sodium ion, at least 1% wrote NaSO4. This is late in the game. We cannot be doing this. And so if you are still doing this, I'm gonna say you need 15 to 20 hours per week for this class instead of 10 to 15 in order to get it together. It's getting late to get it together. Somebody wrote Na2S, sulfide ion. So S is sulfide ion, S2 negative. Sulfate ion is SO4 2 negative, please. And then there is 2H2O, dihydrate means 2H2O. And some of you could not do that. Isn't that sad? Some of you gave me separate percent for hydrogen and oxygen. I'm asking percent for water. Why are you giving separate percent of hydrogen and oxygen? I don't know. So you'll have to explain that to me, why you did that, so that next time I can improve your understanding of it. 2H2O, di. Everybody knows di means 2 in this class. You're supposed to memorize those 10 Latin prefixes. You're supposed to be able to count in Latin up to 10. If you don't or forgotten, you should know where to go to find it. It's in the last but one page on the guidebook. So that's where you go, and they are in bold letters, so that would be easy for you to find them. Okay, so di. So some of you did not consider that di, and you gave 18 grams for water. That was good, but 2, so there's going to be 36 grams of water for 1 mole of this formula. And then you have to add all the atomic weights, including the water, in order to find the total weight of the hydrate, which most of you did. A couple of you missed that. Okay, then dimensional analysis. I still see people not doing dimensional analysis, just a few of you, and doing X, and I don't really care for X, as I told you before. With X, you guys are very likely, with a complicated problem, you won't be able to do it. Guaranteed, you won't be able to do it. And dimensional analysis, you got to learn this new method because your life will be easier in chemistry 1B. Otherwise, you will be totally lost. You'll be gone without dimensional analysis. So, and you should know it by now. In chemistry 31, the earlier chemistry course, somebody must have taught you dimensional analysis. So why are you still using X? I mean, I know why are you still using X, because a person like me, I have a habit. I keep on doing the same thing with the habit, and I do that too. It's not like you do it. And at times I have to make an effort to get out of that habit. Otherwise, things are not going to improve. So that's what we all have to do. Yeah.
Hey, Professor. So I know you don't prefer X's in dimensional analysis. What would you like us to use instead?
Dimensional analysis. There is no X in dimensional analysis.
Don't you multiply each conversion over each other?
Very good. That's what we do. Now, this is a very important question, so let me go deeper into it, all right?
Mm-hmm.
Okay. So when we write X, we do not write units. I don't want any number without any units, except there are a few numbers that don't have units, like percent does not have unit. If it is a ratio, it does not have unit. There are very few other things like that which does not have unit. But otherwise, there has to be a new unit. So I don't want X because X does not have any unit. And if you write unit with X, well, that is slightly better than otherwise. So the general format of dimensional analysis is this.
Oh, sorry about that, Professor. I was confused with what X you were referring to. I got it now. Thank you.
Okay, anybody else want me to go into this general format of dimensional analysis? Because that's what I want. Just like what you were saying, take your starting quantity, multiply it with the conversion factor, multiply with the another conversion factor, multiply with third conversion factor if you have to, and this is what that is. Okay, thank you for letting me know that. I am sorry if I sound like I'm lecturing you. I guess I am lecturing you and kind of disappointed in what's going on in the class. And
I would say ultimately, I feel like the actual number of problems isn't too bad, but I like to show a lot of work. I don't know if you noticed that on quizzes, and that just me writing out all my steps because I want you to see exactly where I got my answer takes more time than me just doing a simple dimensional analysis.
Okay.
Yeah, same here. Every time I type it out, it's a lot longer than me writing it out. Like if this was a written test or a quiz, I would be able to complete it in time. But because you have to type everything out, it takes me 3 times as longer.
3 times longer. All right, we'll look into that. Now, so I have seen one person. I don't know who it was that was talking because I did not have that I did not see it. But anyway, one person gave me very good detailed answers. And I was very pleased, and I wrote that down actually, that this is where, this is you're showing me all the steps and all that. I did write that down. So I appreciate that, and that shows me that you really understand it, and that's a nice thing for a teacher to see. Oh, yes, a very good understanding, one step at a time. So I actually appreciate that. And what you are telling me is that when you do that, it takes more time, and printing it out, it takes more time. Now that's what I need to consider. This is one of the things I needed to know from you, and you are telling it to me, and I am listening and I am understanding it. So good, thank you, appreciate that. Now,
Professor, you can do like just a suggestion on like the quizzes and stuff like that. You can give us the problem. We'll do it on the paper and submit it in as a PDF. That way we have time to write it out. But you can't time us though.
Say that again. I did not quite understand one word in there.
Okay, so you know how like on the quiz you timed us, like you give us like a certain amount of time to do the quiz.
Yes.
Instead of doing it and giving us the boxes for the text, you should give us just the problem. We'll solve it on a paper and then submit it to you as a PDF. That way we have time to do it. And it's like Lisa said, it's faster to write it out than typing it into the box.
Okay.
But you can't give us a time limit on the quiz because then that's still,
All right.
Or maybe make the time a little longer.
Okay, I hear the suggestion. Maybe make a time a little longer. Maybe you can do the PDF so that you can write it by hand and not have to print it. Those are the 2 suggestions here. So let me address those 2 suggestions. Suggestion number 1, you send it me with PDF, or you are going to send me a picture of it. That would be easier because it will take less time. I understand that. Now, on my part, when you do that, I will not be able to give you very good feedback because I cannot write on that thing. So if you give me in the box, then I can give my comments right on there. So if we are going to do that, then you will get less comments, less feedback, or I can give you just the feedback. What do you think about? Well,
Because
hold on.
well, I don't know if you like, I don't know if that's something that, because I remember submitting the PDF file for the experiment for the lab that we recently did, the limited reagent one,
Yes.
and you did wrote it directly on the PDF. Like you left us the notes for the extra for the trial one that you want us to calculate, and you did write it directly on there, like you typed it out.
Yeah, that's a little hard to do, but you are right about that. I haven't figured it out. Sometimes I'm not able to write it at all, nothing. And so I have to write it on the separate page where it says comments. And sometimes I am, and I have not figured out what is going on there. So some of the time the PDF thing works and sometimes it does not work. So is the PDF or is it anything else? Anybody knows? I have to investigate into that, and I have not investigated that yet. So that's PDF or and what was I saying? Oh, it'll come back to me later. Okay, the second part, giving you a little more time. It's a question of how much little more time. 5 minutes, I can understand 30 to 35 minutes, but after that, I think it's not, I don't feel like doing that, but I have to think about it. It's not a question of feeling like, it's a question of having some reasoning behind it. So feeling is not enough.
Well, I think that maybe should be based on how the class is doing. Like on this last quiz, the average wasn't too high, right? So maybe just try to bump it up a little bit and see if the average goes up, and we just based it on that.
That's one suggestion. Okay, thank you.
What about if we give you just the answer on that and then send you through email a paper with like
No,
all
it's
the
very difficult.
written?
I'm sorry, I'm jumping in there. But when you send something to me with the email, I cannot write anything on it. I have to write separately. I have to write on a different thing, and then I have to connect it back to your page, and that is something I really don't want to do. When you have to do it, I do it, but I don't want to do that. That's just, and some of the time those emails get lost within certain emails, or I don't get to it because I don't see them, or something like that happens, and that's not fair to you. So email is something I'm really discouraging you to do. If you have to, you will do it, and I will look at it, but it will take me more time, and it definitely will not get enough feedback. If you have everything right, then I will be very happy, of course. And then I don't have to do anything. I just have to say, oh, all good, or this is good, and then I'm done with it. That's fine. But if I have to correct it, it's very difficult to do email. Okay. I have a number of suggestions here, so thank you for that. Now let's see. So here we have question number 5. Calculate % water in sodium sulfate dihydrate. You have to know how to write the formula of sodium sulfate dihydrate, and that should happen within 30 seconds. Okay. Next. Most of you understood that % water meant part divided by whole multiplied by 100. So that was good. And the whole is the whole thing, sodium sulfate dihydrate. Many of you understood that, and you found the total mass of sodium sulfate dihydrate. That was good. Some of you did not do that. You just do the mass of sodium sulfate. And then a couple of you did not understand, as I told you, di means 2 water, not 1 water. You just wrote about 1 water. Okay, so this is a dimensional analysis problem. I don't want you to set up anything else. You just write down just the setup of dimensional analysis. Most of the time now, I'm not going to ask you what is the starting quantity and what is the conversion factor and what is the solution map. We already have talked about it, and you know the solution map for these things. So you don't need to say that. So our dimensional analysis problem shouldn't take you much time. That's what I would say, because I'm not expect you to write the steps. You just show me the setup and the answer. Okay, number 5. Number 6. Calculate the weight of one molecule, not 1 mole. I'm telling you, why am I putting this one molecule in bold and with underline? I want you to pay attention. And you cannot tell me Cl is 1 molecule, please. Ugh. So that's 70.90 grams. And 1 molecule is the starting quantity. And many of you knew what to do. So that was good. Some of you did Cl instead of Cl2. Okay, next time you won't do that mistake. That is the point. The point of the quiz is help you understand where you are making the mistakes, and you are not getting penalized much at all. Out of 10 points, I mean, you know, what penalty is going to happen. But in the exam, you will not make those same mistakes because you are going to learn from your quizzes. And in the exam, you are that particular mistake would cost you more points, 2 to 4 times the points. So if you learn from your quizzes and you do it right in the exam, that's the point of the quizzes. Okay, number 6, number 7. I am telling you this is a limiting reagent problem. I am telling you that. And I have told you, and the way it is presented in the guidebook is that you do 2 stoichiometry, you do 2 setup, and you get the answer, the smaller answer, that is the correct answer. And I said many times, or I said very carefully, please do it this way, because if you're going to do it other way, some of you are definitely going to make a mistake. And I saw that again. And a number of you wrote numbers without units, and I don't care about that, really. If you write 3 or 4 numbers without unit, I am saying this person doesn't know anything. So maybe a number of you learned the same way of doing this because you showed me the same way. And I was surprised that every 4 or 5 students used the same method and they had the same kind of mistake. And I wonder what happened, that they were in the chemistry 31 class before and this is how they were taught to do. I don't know. Or maybe you were in a study group and you learned it that way. But I don't want you to do it that way, because I'm telling you again, out of the 5 people who does it this way, 2 or 3 people are going to make mistake. Like this, I had to write down, you cannot compare oranges with apples. You compare moles of sodium carbonate with moles of this oxalic acid. You can't do that. You have to compare moles of oxalic acid to moles of oxalic acid. So you go grams of oxalic acid to moles of oxalic acid. You stop over there. You take the moles of sodium carbonate. You take the grams of sodium carbonate. You convert that into moles of sodium carbonate. Then you convert that into moles of oxalic acid, and then you compare these two. If you want to go the comparing way, I'm telling you, please don't do that unless you are a very good student and you understand what you're doing. Otherwise, just do stoichiometry. What time does it take? Almost the same time. You know how to do grams to moles to moles to grams. So just do 2 grams to moles to moles to grams. I'm telling you, it's a limiting reagent problem. There are 2 starting quantities. And you should know how to do grams to moles to moles to grams. It's a very basic thing. So please take care of it that way. I gave you molar mass 106 grams, and then somebody wrote down molar mass 99 grams. I have no idea. 2 or 3 people did that. How would you make the same mistake? I wonder. It makes me wonder. I won't go into that today. But why would you write down 99.1 grams for the molar mass of anything? And nothing here is 99.1 grams. As I told you, there is a typo here. I already told you about that. There's hydrogen does not belong there. It should be Na2CO3. Okay, that's taken for, I understand that. That's my mistake. So when somebody wrote down, hey, there is no Na2CO3 in the equation, I said, okay, 4 out of 4, just for that, fine. It's my mistake. So I should not penalize you. But you could also do that. Is an NaHCO3. Instead of that, you can write NH2CO3, and you know how to write an equation. So you could have just changed that to yourself. And if you did that, where did the 99 gram come from? I have no idea. Okay, so that's limiting reagent problem. And what I have told you before, I'm telling you again, is going to be everywhere in the exams. Limiting reagent problem with the how much is left over. So you don't have any excuse of not knowing how to do it. And if you still need help, I am here, or there are other chemistry teachers available, other chemistry tutors available at STEM Center. So you go to STEM Center, you find out their timings, and then you can go there, and they are fine. The tutors are either teachers, or they are tutors who have been taught how to tutor. So if you don't have time with me, you need to go over there if you need help. I got it done with. Okay, number 5, number 6. Calculate, oh, we already did that. Number 7, number 8. How many moles of chloride ion in 1 mole of lead 4? I changed it to a lead 6 over here. And I do take it that was my mistake. So if you wrote 6, I said, oh, well, that's my mistake, so I have to deal with it. So I said that was okay. And there was one question which was exactly the same as this question. This question number 3. There was a last question over there. I got rid of that now. So the way I look at it, I heard what you have said, and thank you for letting me know so that I improve situation here. But as I was saying, this question take at the most 1 minute. This question take maybe 1 minute or maybe 2 minutes at the minute. This question take 1 minute. This question, if you just write down dimensional analysis, or this is not dimensional analysis, if you just do the calculation, the molar masses, if you have to know this formula. Half a minute for the writing the formula, correct formula. Is a minute if you don't know the formula and if you know where to find it, but no more than a minute. Then you are going to calculate the molar masses, which should take a minute or something like that. Then you are going to say part divided by whole multiplied by 100. That takes another minute. So this is a question of 3 minutes or 4 minutes at the most if you have something else. Don't see anything more than that. And I don't expect you to write anything more here. That's what you need to write. That's all.
So Professor, for this one, rather than writing out each individual weight and then showing all the work, you just show the equation and the answer. Because on here it says show all work. And I didn't want to get points taken off if I didn't show all the work, but you're just looking for the equation and the answer.
What I'm looking for is the molar masses. That's right, the equation and the answer. And all work, that's what it means, because by now, I expect you to do the molar mass. I'm not going to ask you to add up and subtract. That's a too simple a thing for you guys to do.
Okay, that's good to know, because that's what took the most time on here is writing each one of these individually out.
No, just tell me the molar mass. Some of the time I give you the molar mass. So what is the point of me asking you to just calculate, each one of them? Just do it, calculate it, and write it down right there. Thank you for clarifying that. Okay.
So for this one, rather than doing 1 molecule equals grams molecule, like the whole setup for dimensional analysis, you just want, and the what's that called, the
Setup.
The setup.
Yes.
Rather than that, you just want the dimensional analysis and the answer, and that's it.
Just the setup, because now I'm not asking you that what is the starting quantity, what is the, so
Yeah.
if
Okay.
I will ask you if that was I want, then I'll say what is the starting quantity, what is the conversion factor. I will ask you that particular question. Okay.
Okay.
Yeah. And from now on, most of the time, I'm not going to ask you that question.
That will cut down time, because I thought you wanted all of the components.
Uh-huh.
And if you just want the dimensional analysis and the answer, then that's different.
Okay, I say show work because I have seen that people just write down the answer. If I don't say work, the final answer, nothing.
Oh, gotcha.
So that's why I have to say show work. That has happened. This, one of some of you students just did that. Just wrote down the final answer. Now that, and with final answer, what happens if it is correct? I might feel like giving you some points. If it is not correct, you lose the whole thing. The total points, all of them are gone. So you don't want to do that. Partial credit, I give you partial credit, and I hope you do the whole thing correctly, so I don't have to give you partial credit because it's more work for me and it makes me feel bad that you don't know enough. So, but partial credit is better than no credit. Okay, we already talked about this. So you see why I am saying that it should take 30 minutes or less for this kind of thing. And if you need more than that, I suspect that you are not prepared enough. And if you are not prepared enough, I am here to help you to prepare enough. So the first thing we do is we go over this over here in the guidebook. And there are 5 points at the beginning of the top of the guidebook. And it tells you what to do. Respecting their learning process or 5 steps to success. This is what I expect you to be able to do. And if it takes 20 hours per week, it takes 20 hours per week. If you are not prepared well enough, some of you are well prepared for this class, it will not take 20 hours. It may not even take 15 hours. It will take 10 hours. But if you are not well prepared for the class, if you still have trouble with Na to SO4, then you're gonna need 20 hours and you're gonna do all this in order to learn chemistry and pass the course and then go to the next course and be successful there. So that's the name of the game. And if you need help with that, you let me know. And if I cannot be, you cannot be in my office hour, there are other people with other office hours. Okay, and most of the teachers at Chabao College, I know, we are happy to help you. We are happy to spend that time with you. Okay. Any other questions or comments about this situation here? So what we have, let me go over what we have so far understood from each other and what we might be looking in the future. So the next quiz, the units are from 14 to 17 and the date is given there, and it would not be on that date because you'll be taking on the date after that or something like that, or in the evening and then the next day. So, and it's going to be 30 or 35 minutes, and I expect you to know how to write the correct formula right away. If you don't know that, you know what happens? You get confused, you get discouraged, and you lose time in that confusion. And the next question, you might not be able to do it right because you are confused. This happens to all of us. I can imagine there are a few traffic accidents that I've had in my life with my car, where because I was confused, that's when those accidents happened. So in the same way, decrease your confusion. Make sure that you know this simple thing that I expect you to know, that this chemistry 1A class expects you to know. It's not me who is expecting you to know. It's the chemistry 1A class that expects you to know. Okay, let's get out of here. Nobody's saying anything else, so I guess we can move on. And we are moving on to Unit 17. Redox reactions. And we already have talked about redox reaction. Now, I need to ask everybody, were you able to do the first part of this? So let's go from the beginning. Okay. Marambire Anoti Daise, please tell me, did you do the first part in your 17 homework?
Was it already due? I think
Yes, it was already due on Sunday. Saturday.
for every yeah, for everything that was due, I did everything.
Wonderful, thank you. So we'll start working on this right now. And if you have any questions, you just jump in and ask questions. So where you are right now, this is something you already have done. So all those people who have done that homework, you are going to start that. And those people who did not do the homework or did not finish it, you are going to go there right now and start finishing it before you do this homework. So that's assignment 17. So you are starting it right now, Mr. Marambire. That's what you are doing right now here. 5 point and start that. And anytime you have questions, you are going to jump. Now, what I am telling you about this is these steps will be given to you in the exam. Do not memorize the steps. As I have told you before, I am not I'm not very fond of memorizing, but there are certain things that makes life much easier if you memorize. Then I will say you memorize, and then you need to memorize those. So those, don't memorize those steps. But you have to know how to apply the steps when they are given to you just like that. That's what the point is. So you are going to apply this right now, starting with number 1 and going to up to that. And let's see what else.
So this would be the homework 17 part B, right?
That's homework 17 part B. If you did not do home 17 part A, you need to tell me right now so that I know who is doing part A, and then I can, if I need to help you, I could deal with it. So how many people did not do part A?
Hey, Professor. I actually haven't done part A real quick, but it looks pretty easy. I'm gonna get it done. Should only take
It's
me-
pretty easy. It is. Yeah.
I haven't done it either, but I'm actually working on it right now.
Yeah, I should have it done in about 5 minutes, maybe.
Yeah, that's what I would say. It's not that difficult.
Okay.
All right. So let's get that. Let's get that done, and then we're gonna do this, and you're gonna individually ask me question if you have any questions. Okay. So please take that responsibility and do ask that question. It's all right. It's all right to ask questions. And you know me, I'm not gonna say, oh, that's this stupid question. No, I appreciate when people ask questions. So, okay, start working on that right now. Very good. Or you already started working. That's wonderful. Now I'm gonna be right here. And if I'm gone, I'll just go for, for a minute to just drink water or something like that. So if you don't see me here, I'll be back in a minute or something like that, or I'll write it down, I'll say, oh, I'll be back or something. So, okay, go for it.
Professor?
Yes.
Okay, so is that one, that the unit 7, that part, is that for part B that we have to submit?
Unit 17, part A, you have to submit. Part B
This
is
page, right? That you're showing, this page, is that the one that we have to submit on that one?
it says that. So let me go back to you and show it to you. Okay.
Okay, because part B, it says we have to submit the assignment page 20 and 21, and those are 20 and 21.
So here we are, and assignment. What does it say here? Unit 17, part B, part A. So this is what some of you are doing, and many of you already did that. And that is just multiple choice question and stuff like that. So you answer it right here. And then part B is right there. And is an assignments. Part B involves questions 2 to 9. The question 1 is not part of part B. So this question here is not part B question, which you already did in part A. So why should I do that? That's why it's not there. So you're from 2 to 9 here on
So,
page.
so to 2 to not the last question, right?
Yeah.
Is part B.
Right.
Okay.
This one is very easy, but anyway, so you already have done that. So why should I ask you to do it again?
Okay, thank you.
Mhm. I'm going to get out of this sharing, and I'm still here, but I'm going to get out of sharing my screen. If you need to share the screen, I'll do that again.
Hey, Professor.
Yeah.
When we're looking at oxidation numbers,
Yeah.
and let's just say I'm gonna do, let's do N2O, for example.
Into
That's that subscript there. So would it be, so I got nitrogen, because O has -2, or oxygen has -2 charge.
yes, correct.
Nitrogen should have a +1, and there's 2 of them.
Oxidation, oxygen has -2 oxidation number, not charge. It's
Yeah,
a
oxidation.
covalent compound, so there is no charge.
Oh, okay.
So -2, so each nitrogen is going to be +1.
Mm-hmm.
Yeah.
And so you're not including the subscript in the actual charge.
We are including the subscript. 2 nitrogen equals 2 positive. So 1 nitrogen equals 1 positive.
Okay, that makes sense.
No, but it's okay. You guys take a little break whenever you want to, it's just do your thing. Don't need to tell me that you're taking a break.
All right, Professor, I'm done with the question 1.
All right.
Just move on to second part B. Hey, Professor.
Mhm.
I did part A in the guidebook. Should I to receive a grade on it? Do you want me to go through part A on the computer and just fill in those answers, or can I just send you a picture of it?
Why don't you share screen with me and show it to me? We'll take care of it right away.
Yeah, sure.
So go ahead, share screen with me.
Can you see it?
Yeah.
Sorry, can you see my screen?
Yeah, I see your screen.
All right, perfect. Yeah, so I did it. I did all the answers in the guidebook. But do you want me to just go back in and plug it in here, or can I
Why
just?
don't you do that? That won't take much. That won't take you much time. Yeah.
Okay, I'll do that right now.
Okay.
Do you have a preference if it's 2 negative or -2?
We write 2 negative. I mean, for that we write -2.
-2.
Yeah, and for charges we write 2 negative.
Okay, sounds good.
But I'm not gonna, that won't be called wrong just because of that.
For some reason, Professor, it's not letting me put in positive.
Oh, because just don't put in positive. Positive will understand.
Okay.
Negative to put in positive is not a big deal.
Okay, sounds good. I'll do that.
Where is it?
Hey, Professor.
Yes.
If you're going to find so like, let's just say question 2, write all the oxidation numbers assigned to manganese. What would be the fastest way to find that? Because I know you could try to combine it with, well, you could try to make different compounds and see what it would add to. But is there like a surefire way to say, oh, this will have this many potential oxidation numbers?
There is a partial way. It works better with some than the others. For
Okay.
metal, we know that the lowest number is going to be 0 because metal cannot have negative charge.
Okay.
So 0 is the lowest number. Highest number cannot be more than 7.
So generally you would just say 0 to 7 then.
Well, not for all metal, it will not work that way, but this is the limitation we are working with for metals.
Okay, for
then,
1A at least.
For representative metal is very easy because we know the charge on the ion.
Mm-hmm.
So for sodium is 0 or one positive, that's it, nothing else. Only for transition metals is going to be different.
That makes sense, yeah.
And then you will have to be given a particular compound.
All right, sounds good. Thank you.
For non-metals, the group number will tell you. For example, nitrogen is group number 5. So what is going to be the negative number for the oxidation number?
Sorry, I was looking for an eraser. Can you say that one more time?
What is the negative number, so smallest number for oxidation number for nitrogen? It's in group number 5.
Nitrogen, let's look at its group number. -3?
Yeah. And then what is the highest number going to be?
0? I can't imagine it being
5.
+5.
Yes, for non-metals is the difference between the two is 8.
Okay.
So
that makes sense.
5, right? So that's
That
positive
makes
5.
sense. Yeah.
So that's non-metal is very easy. It's just for transition metals, somebody has to tell you
Okay.
which one you're talking about.
That's perfect. Thank you. So, Professor, for transition metals, we can't use that same rule of 8. So it wouldn't be
It's a
positive.
rule of 7. But but that doesn't work for all transition metal. Don't worry about transition metal because I have to tell you which particular compound I'm using.
Okay, cool.
So in case of magnesium, manganese, I give you all the compounds so that you would know which one would be the highest.
Perfect.
And I don't expect you to come up with those compounds.
Hey, Professor.
Mhm.
And the rationale why KMnO4 cannot be a reducing agent, is it because Mn at that point is at +7? You can't be reduced anymore?
Yeah, a little bit more than that, 507, so what?
Sorry, one more time.
Little bit more than that. Keep on going.
Okay.
Then one more sentence.
Can only decrease. So it's an oxidizing agent.
Mhm.
Okay.
Can it give up any more electrons?
Okay, that makes sense.
No, it cannot give up any more electron. It has given up all the valence electrons. There are no more electrons to give. The valence electrons are not there anymore. The maximum valence electron a metal can have is 7.
Okay.
Professor?
Yeah.
I had a quick question for oxidation states.
Yes.
So, for number 9, part B, I was doing it, and the chromium ion 3 plus, chromium 3 ion,
Yes.
the oxidation state's still 0.
No, 3 plus. The ion
So,
has
it
the
would be
same oxidation number as the charge.
oh. So when it's an ion, the oxidation is the number of the charge?
Yep.
Okay, thank you.
Because charge and oxidation number are very similar. As I have said, charge is like we are Californians, and oxidation is like we are Americans.
Mm.
So if you are Californian, then you are American, definitely.
Okay, thank you.
Hey, Professor.
Yes.
So the reason that manganese and all metals can only be reducing agents is it because they're positive charge, or what's a good rationale for that?
Okay, what is the definition of our
Definition of a reducing agent?
yeah, or oxidizing agent, one or the other? Reducing, what does that mean?
It reduces the charge.
The reduces the charge, right? In order
Okay.
to reduce the charge, you have to take in oxygen electrons or give electrons.
To decrease the charge, you'd have to take electrons.
Give electron.
Oh, you'd have to give electrons.
Can metals give electron?
No.
Yes.
Okay.
Sodium metal gives electron to become sodium ion.
Okay.
So can metal takes in electron? Do they have negative ions?
No.
No, that's why.
So they can't take electrons, but they can give them.
Right. So that's why they can only be reducing agents.
Thank you.
Now metals, we are not talking about metal ions. Metals can only be reducing agents. And metal ion can take electrons, of course.
That makes sense.
Can you explain number 4 to me, please? Why K2MnO4 is a reducing and oxidizing agent?
Yes. What is the definition of an oxidizing agent?
It
What
takes
does
electrons,
it do? Take electrons or give electrons?
gives electrons.
Oxidizing agent. Okay, give electron or take electron. We don't know. Suppose we don't know. What one substance you definitely know is an oxidizing agent?
KMnO4.
Oxygen.
Oh,
Yeah. The name says oxidizing agent. Oxygen has to be oxidizing agent. That's where the name comes from. So oxygen is the oxidizing agent. What does oxygen do? It's a non-metal. Does it take electron or give up electrons?
it takes.
So that's what oxidizing agents do. Oxidizing agent accept electrons, and the reducing agents give electron. Like metals are reducing agents. Non-metals are oxidizing agents. Make sense?
Yeah.
Yeah. So this is how you can, if you forget, there is nothing to remember. It's just reason it out like this. Now,
So it's because it can take, sorry, because it can take and give electrons?
got it.
Okay. Thank you.
And you do need to say that its oxidation number is 6.
Mhm.
Increase to 7 or it can be decreased. Both can happen.
And the oxidation number for N and P is 0 to +5, right?
For what? Na?
For nitrogen and phosphorus?
Nitrogen oxidation number. Can nitrogen make negative ions?
No.
Yes.
Oh,
All non-metals make negative ion. What is your charge on negative ion of nitrogen?
-3.
Yeah. Because it's in group 5. 5 minus 8 equals -3.
So then inherently by the rule of 8, then it would be what, -3 to +5?
That is correct. Yes.
okay.
So for all non-metals, the group number is going to tell you what they are going to be. And
Okay.
there is a distance is 8 for non-metals. So -3 to +5 is 8. So what would be the oxygen highest number?
It's -2.
It's in group 6, so it will be 6.
Okay.
And that can happen only with fluorine, because oxygen will not give electrons to anybody else but fluorine.
Okay.
And therefore fluorine is a very poisonous substance, because if it gets in our body, it'll take away electrons from all the oxygenated, all the compounds with oxygen, and we are in big trouble because our enzyme will stop working.
So then to answer the second question, it would be because it has to do with the grape and they only have a range of like 8.
They have a range of 8 for non-metals.
Okay.
So that's what we are limited to, yes. So to answer the second question, which second question? I don't know.
It was the second part to 6.
Oh, second part to 6, okay.
Mhm.
Nitrogen and phosphorus they are in the same group, so that's going to be, as you told me, -5 and -3 and +5. How are these numbers related to the position of N and P in the periodic table? I already talked about it, right?
Mhm.
And now, so what is your question now?
Oh no, I already put down my answer.
Okay, good.
Thank you.
hey, you guys, I see this again and again, not writing charges on ion. Why don't you write down on a piece of paper, write charges on ion, and have that in front of you when you are doing the homework and the exam, so that I don't have to see that again and I don't have to take away points. I mean, these are a few things. You should just write it down on the big letters. Here it is. And then keep on reminding yourself.
Sorry.
Uh-huh.
Oh, I'm sorry. I was gonna ask a question. So sorry, hold on, just give me a second.
Okay.
Sorry about all the noise. I was gonna ask, since you know how, for example, homework 17, it has it in two parts. Do you prefer all of it to be submitted together or to do it in parts?
The first part is submitted out there.
Okay.
The second part you will submit separately.
Okay.
The first part, do it on the computer. And
Okay, okay.
do it the way it's given. Just answer the questions there.
Okay, thank you.
Hey, Professor.
Mhm.
Any chance that we could walk through number 7 together?
Sure. Write the smallest and the biggest. No, that's 6. Given the steps to balance the redox reaction, use given steps given below.
Mm-hmm.
Okay. Use given steps to. All right. So, okay. Start taking the step. And start talking.
Let me actually, sorry. Well, let me try to do this by myself real quick. I'll call on you if necessary. Sorry
All
about
right. Okay.
So for the first part of unit 17, we're not putting down the charges, right? Just the number?
The charges, we are not doing any charges. We are doing oxidation numbers.
Okay, so we're just writing down the number, right?
Yes, a number with a positive sign or negative sign. A positive sign is not important. Negative sign is important.
Okay,
One
because
negative or three negative or whatever, anything like that.
right now that I'm doing it, it's not letting me put a negative sign.
Uh,
So it says only numerical values are accepted. Do you want me to just submit it like that, or
whoa.
I can like take a picture of it and send it to you on Canvas too?
No. That's too much. You would think that -3 is a numerical value.
Yeah, yeah, it won't let me.
I know.
I tried doing it before and after.
Making me
Oh
laugh.
wait, it does if you do it before, not after. Okay, never mind.
Okay, all right. How did that happen?
Professor.
Yeah.
So for 7, number 6, use coefficients to equalize the number of electrons lost and gain. Balance the equation by inspection. I noticed on the explanation earlier in the guidebook that you're looking for a common denominator between the two.
Right.
And so the common denominator I found was 3, 6, 9, 12. Was 12. I don't know if that's right.
3 and 4.
Oh, is it? How much did nitrogen? Nitrogen's 3, right? It should be 2 and 3 is what I got.
Plus 5.
Yeah, plus 5. Nitrogen plus 5, and then it goes to plus 2. So that's
Plus 2. That's 3.
3.
That's 3 electron exchanged, and copper is not changing.
Doesn't copper go from 0 to 2 plus?
Good. So that's 2. 3 multiplied by 2 is 6. So that's 6 is the common denominator.
Oh yeah, obviously. Oh my God. Thank you.
Professor,
Yes.
what does the question 11C mean when it says write the empirical formula with a higher number of oxygen symbols?
Yes.
What does that mean? Like, we want to find a formula that has a lot of
Write
oxygen.
the empirical formula first. You know how to write that, right?
No, it doesn't. It just says write the empirical formula with a higher number of oxygen symbols.
It says write the empirical formula for oxalate ion.
What? Oh, mine says write
11B.
11C.
11C. Write the empirical formula with the highest number of oxygen symbol of. Now between the two, 11A and 11B. Between
Oh,
11A and 11B.
okay. Thank you.
Mhm.
Professor, after we finish 17B, what do we do?
All right, 17B. So you are done with 9 and 10 and all those doing the balancing the equations. You are done.
Yeah.
And so 11D is finished.
Mhm.
All right, take a 15-minute break.
Okay, thank you.
Okay, nobody else seems to be talking, so that means they are doing fine with the homework. And you are almost done with it, that means. So in 15 minutes, we're gonna change the topic 33, 37, 340, and 355. About 355, we're gonna do a little bit something else. So get that done by that time. And if you are not able to do that, with 10 minutes before that, you let me know so that I can help you through.
Sounds
So
good.
next 15 minutes, get the homework done. If you are far behind, you need to get help from me.
Professor.
Mhm.
So I'm a little behind. I'm still balancing the equation for 7.
Yes.
I'm just having a little bit of a hard time conceptualizing it.
Uh-huh.
I think if we just go through it as an example, like I'm getting the amount of electrons lost and gained, finding the coefficients fine, but then just balancing the equation. I know there's an example on the page before, but I'm still a little confused by it.
Okay. So are we? Copper plus HNO3, can we do that one? Or are you done with that? That's a little hard one.
Copper and NO3. Sorry. Are you doing 7 still?
Yes, that's the copper plus HNO3 7. Yes.
Oh, yes, yeah. So I have the number of electrons lost and gained between the copper and the nitrogen,
Okay.
and we found the denominator, the common
Right.
denominator of 6.
Right.
And so, do we just use that? So would it be? So when balancing, would it be 3 C copper NO3? Or would it be 3 Cu?
3
Well,
Cu. Yeah. Okay. Now with HNO3, I want to do, you need to do something here.
Mhm.
Start with. How many nitrates are in the other, in the product side?
We have 1, 2.
2 nitrates. Therefore, you're going to have 2 HNO3.
Yes.
And then you're going to have more than that because that nitrogen is also going into NO. So
Yep.
you need to decide how many more you're going to have.
Okay.
So 3 Cu, that means 6 electrons are exchanged. And here we have 5 going to 3. So you're going to need how many electrons? 3 electrons. 5 to 2. So there you are adding 3 electrons in to nitrogen.
Yes.
And we need to add 6 electron. Yes. So you need 2 HNO3 for that. 2 HNO3 for nitrate ion and 2 HNO3 for that. So total HNO3 is how many?
4.
4. So that's what you're gonna do. Is that making sense?
Kinda.
So that's where a little bit harder one, because you have to take care of these 2 nitrates separately. Then 5 plus 2, 2 plus. So that's 3. And,
Professor, can you share your screen if you're writing it down?
yes. Okay. Which problem?
7.
Yeah, I have it right here. I can make it. Oops, what happened? I lost it. Okay, there. What I don't have is 200%. 200% is fine, right? If it is not fine, you guys you folks let me know.
Okay.
Okay, here it is. So what do we have here? Step number 1, oxidation symbol, elemental symbol whose state changes. Change. ONH, we already did do that.
Mm-hmm.
Over here, I write it down like this. Annotate. Raw. So I write down Cu is 0 over here. And Cu over here is 2 plus. Everybody, pay attention.
I got this part too. I think I'm stuck where he is, because for NHO3, I got +5. And then the NO, I got +2, right?
We're going to go from here to here like this.
Yeah.
This is +5.
What is there in the
Now we are going to say 2 electron lost. Or you can say -2 electron. You can say +3 electrons. Like that.
Mm-hmm.
Okay, 2 tie lines, we do that.
Yep, we did 3 already too.
Determine the right number of electron lost and gained on top of the tie line. So we did that. Okay, fine. Number 4, use coefficient to equalize number of electron lost and gained. Balance the equation by inspection. So we need to have this 3 go over here. 6 electrons is the electron exchanged, because that's the common denominator. 6 electron exchanged. So
Okay.
3 copper will exchange 6 electron. And now we are gonna need here 2HNO3 to, oh,
Oh, okay, that makes sense though. I think that's good rationale.
okay, and then you have to see that this nitrate is not changed. 2 nitrate here are not changed, so I need to have 2 extra nitrates, so 2 plus 2 I need to have. Now here is going to be 2. Everybody got that? It's gonna be 2 over here.
Yeah.
6 electrons are exchanged, that's where 2 NO. And now we're gonna use balance it by inspection. So that's one of the inspection is that 2 nitrate here, so I need 2 nitrate here, so 2 plus 2 equals 4. Now I say, all right, how many hydrogen? I have 4 hydrogen here. I need 4 hydrogen here, so I'm gonna say 2H2O.
Okay.
I have how many oxygen here? Well, I have 2 oxygen over here and 2 over here, 4 oxygen here. And I have to understand that
You have 12 on the left side.
because I have 4 here and I have also 6 here, so that's 10.
Oh, so that works.
And then this is gonna be 6 plus 4 is 10, and this is 12 over here, so that's a problem there. Oh, but here is I have no, see, I have to also write 3Cu over here. Yes. This is 3Cu, so I have to write 3Cu over 3 over here, right?
Mm-hmm.
So then it works out after that. 3Cu annotated true, and that
I think that would be more though, right?
it will be more than that, yes. So if I write 3Cu annotated true, then I have how many nitrates here? 2 and 6 nitrate. And out of that 6 nitrate are, out of the 6 nitrate, 2 of the nitrogen are connected over here, but then it's going to be 6 nitrogen here and 2 nitrogen here. I need 8 nitrogen over here, so I need to have 8 over here.
Okay.
And that does it. So that's the last part.
Okay, and then H2O would go to 4 H2O.
H2O will go to 4H2O, yes, yes. And then everything else is balanced now. So what we did not do, we did not put this 3 over here because there's 3 copper here, there must be 3 copper over here. And this one is a little hard one to do because this nitrogen is in 2 places. That's what makes it hard. Okay, keep on going now.
So for 8, we're pretty much just writing exactly what we did for 7.
Well, that's the steps,
Yep.
right? Same steps.
Professor, you're showing somebody's work on the screen.
Sorry, what?
You're sharing somebody's work on the screen.
Oh, thank you, thank you.
That's private stuff.
Thank you, thank you, thank you.
You're welcome.
I want to do that. Okay, it looks like you guys are going to going to need more time to finish it.
Yes, please. I'm moving through, but maybe
Okay.
a couple more minutes.
Okay. Everybody else, please speak up. I wanted to go into something else at 3:55, but that's okay. We need to finish this first. And you need to speak up if you need more time.
Professor, you say you're having office hours today, 5:30, or
Yes.
okay? Is it the same link as the other times you have it?
Oh, yes.
What was that?
Yes.
You okay?
Hey, Professor.
Mhm.
I'm pretty sure I'm done. Yeah, I think so.
Okay, great.
Professor.
Mhm.
For writing the smallest and the biggest oxidation number for nitrogen, and then I don't know what P stand for. I think it's number 6 on the homework.
Yeah.
So for like, I'm just taking a guess. For nitrogen, the smallest for nitrogen is 0.
I mean, nitrogen cannot give up electrons.
Huh?
0 means nitrogen cannot give up electrons.
That's the smallest, right?
Well, nitrogen is a non-metal. Non-metals give up electron and they make negative ions.
Mm-hmm.
So what is the charge on the negative ion with nitrogen in it?
Negative charge.
What is how many negative?
2.
No. Nitrogen is in group number 5. What does that mean?
3.
Yes, -3. So that's going to be the smallest number for nitrogen.
Okay.
And the highest?
5.
Yep. That's the group number 5. And the distance is 8 electrons for non-metals. Are you done with almost everything else?
Yeah, just going through it again.
Good, good, good,
Just double checking.
good.
What about P?
Phosphorus is in the same group as nitrogen, right?
Let me see. Gotta look for it on the, yeah, it is.
So then is that exactly the same thing?
So then it would still be -3?
Yep. What is the name of that ion with -3 charge on phosphorus? All the monoatomic negative ion use one suffix. What is that?
Are you asking me?
Yes.
Oh, what was the question again?
All the negative ions with monoatomic negative ions, they have a suffix. What is the suffix?
I don't know.
Well, just look around and make a negative ion. What is a negative ion for oxygen? What do you call it? What is a negative ion of chlorine? Well, you know that one. Everybody knows that one.
What's the negative ion for chlorine? I
Yes.
don't understand like what you want to ask.
Negative
Uh, Chlorine makes a negative ion. All non-metal makes negative ion. What is the charge on the negative ion with the chlorine? Negative.
1.
What is the name of it?
Oh my, come on. Bro.
Chloride?
Yeah. So which suffix are you using? How did you change the name?
I don't know.
IDE.
Yeah.
Chlorine chloride, right?
Yes.
So what would be the name for phosphorus? Chlorine chloride, bromine bromide, oxygen oxide, nitrogen nitride, phosphorus.
Mm-hmm.
Well, tell me.
Tell you, what am I telling you?
What is the name of the ion with phosphorus with 3 negative charge? What is that ion called? It's a monoatomic ion. All monoatomic ion have ID suffix. So put ID suffix at the end and say the name.
You want to help me out?
Chloride, bromide, iodide, sulfide, oxide, nitride, and do you understand the pattern or not?
phosphide.
Phosphide. That's the pattern. We need to pay attention to the pattern.
You say chlorine,
Chloride,
chloride. Oh yeah, chloride,
bromide, iodide, oxide, nitride, fluoride. and
Nitride.
phosphide.
There's a pattern.
Yes, ID is the pattern. All the names are the at the end. They aren't the same. Aren't they the same at the end?
Yeah, with
That's the pattern.
IDE, right?
Yeah, that's the pattern. So you
Okay.
just phosphorus phosphide. Selenium. What would you call that ion?
Mm.
Put ID at the end. What do you mean by you don't know? You know it. You just don't want to say it. You don't know how to say
I
it.
don't know what you're saying. Like, I don't know what you're asking me. So it's confusing me to answer your question because I don't know what you mean.
What is the name of the ion that is made up of the atom selenium? It's a negative ion. It's a monoatomic ion. What is the name of that ion? Name of the ion that has chlorine in it is called chloride. Name of the ion that bromine is called bromide. What is the ion called that has selenium in it?
Selenide.
Yeah, that's the pattern.
So basically just putting IE.IDE.
ID at the end, yeah, just change it. So pay attention to all the patterns. That makes life easier, right? You only have to know one thing, that monoatomic negative ion is IDE end. You don't have to know the name of all the ions because you can make them up. Okay, I need to talk with everybody now and see where they are at. Let's see. Calderon, America, where are you at?
I'm on the second page. I'm almost done.
Okay, Cindy Garcia, where are you at?
I think she's stepping away from her computer for a second.
Okay, thank you. Okay, Mr. Barrera, I already know. Lisa, where are you at?
I'm on the second page, 9B.
So almost, let's get that done, please. Okay, Makaya, where are you at? You don't have any questions, Lisa, right?
No, I don't have any questions.
Makaya, where are you?
I finished.
All right, all right. Operosa. Oropesa, sorry. Oropesa, where are you at?
I'm good. I'm already done.
All right,
I'm just gonna go over it later on by myself.
good, good. Vivian.
I joined class, or I joined this segment of the class late, so I wasn't able to go over.
Okay, you're going over something. You need help?
Not at the moment.
Okay, Sarah Karima.
I'm on 17B on the second page as well.
And is it all making sense?
Yeah.
Good.
So far, yeah, it is.
Okay.
I have a quick question.
Yes, go on.
When can we pick up guidebook 3?
Oh, I have to order it. I have not ordered it yet. I will let you know. And we have some time before guidebook 3 is going to come in.
Okay, thank you.
Yes, all right. And let's see, Vivian Lynn, how is it going?
You just called on me.
I just call your name. I like your name, so I said it again. Thank you for that. Vince, Fran Vince. Vivian, what does that mean? Is that means full of life? I wonder.
I searched up what it meant before, but I completely forgot. My mom doesn't
You can always ask Alexa. They are good for this.
That's very true.
It sounds like, full of life. That's what it sounds like to me. Okay, Vince, where are you? How is it going? Any questions?
No questions.
Okay, where are you right now?
I'm already done.
All right. Well, just tell me that then. Okay. You have any other questions that we can deal with right now? This is a good time to, you guys, whoever else has other question, they are done with it. This is a good time for us to do the other questions. So, Vince?
Yeah.
Think about other questions. Anywhere else you have confusion or you don't quite know what to do? You can go there.
Not at the moment.
Not at the moment.
Yeah.
How are you with this IDE business with all the naming? Should I quiz you?
Going all right.
Should I quiz you? Find out how you are. Would you feel okay about that? I don't want to put you on the spot really, but if you feel okay, we can go out do a few of those.
Nah, I think I'm a little rusty.
All right.
I'm gonna look at it.
And where are you going to look at?
I'm gonna look at the names.
Yes, but where are you going to look at in the guidebook? All the information about nomenclature is on one page. Where is that?
The back of the guidebook.
The back of the guidebook, the last but one page. Can you open it for me, please, Vince, please? Vince?
Okay, I got it.
Okay, what does it say on top?
Naming elements.
Naming elements, very good. So that's where it said all the information that you need for this class. So if you want to know about which positive ions have to have Roman numerals, where would you look? You would look at ionic compound, and then you look at under ionic compound positive ion, and under positive ion a cation, and under cation you would look for transition metal ions. You see that?
Yeah.
And then under transition metal ion, which two transition metal ions are exception to the rule? You don't have to write the Roman numerals for them.
AG and ZN2.
Right. AG1 plus and ZN2 plus. Very good. So that's how you, and what is number 7 called in Latin? Where do you find that information?
Say that again.
Number 7. What is the Latin name for number 7? Now, these Latin names are used for covalent compounds, so you're going to look under covalent compound. And they are given to you in bold, all the Latin names. You see that? You see that? Under covalent compound, there are lots of bold thing in there.
On the same page?
Yes, so everything is on one page. Everything that you need to know about nomenclature. That's right, on the same page. Where is the covalent compound? Ionic compound is on the right and covalent compound is on the left, right? Correct? Vince, you see the covalent compound on the left or not? Left on the top.
Yeah, I see covalent compound.
Okay, Now, in the covalent compound, there are lots of, there are certain highlighted in bold. Those are the Latin numerals. Start reading them.
Professor.
Di, tri, tetra,
Yes, penta,
hexa, hepta,
hepta. So
octa.
hepta is 7, octa is 8. That's what it said. So I want you to read that one page very carefully and note everything so that life is easier for you. Okay?
Okay.
Good. Now somebody else had a question.
No, it was me, Cindy. I had to step away to find my charger. My kids left it in the front house. I believe you were calling me.
Well, yeah, just wanted to know how you were doing. That's all.
I'm doing good. It's just my computer started dying and I couldn't find my charger. Sorry.
Yeah.
Like my kids left it in the front house. So sorry.
No.
I was going crazy.
Okay.
Sorry.
Hey, Professor, I had a quick question.
Yes.
So for question 9 on the Unit 11 redox reactions homework, part B. So it's written out as the ionic or the net ionic equation. Do you want us to combine the equation to the molecular equation and then solve for it, or do you want to just leave it as the net ionic equation and solve from
Well, I
there?
don't know what it says exactly.
So there's a iodide ion, hydrogen ion, C2 dichromate ion, and then that transitions into I2, H2O, and chromium ion.
Okay, you need to write the molecular equation for it.
Okay.
And the spectator ion is given?
I'm assuming the spectator ions were taken out because there's none in this equation.
Right, it should be given to you.
It doesn't state it here, the net ionic equation.
Huh.
It might be in the printout. If you want to take a look at it.
Okay, I'll take a look at it.
Professor, could you look at number 9 for unit 17, the one that we're doing?
If you have it together, share the screen. That way it will be faster.
I don't have it on a computer. I have it on my paper.
Oh.
Well, because I don't know how to, because you say balancing the redox reaction. I don't know how to balance it. I tried it a couple times, but it didn't work out the way I wanted to.
Okay, let me go there then. Hold on. Do you have your... No. Okay, I'm there. Which 11 you said, huh?
9.
9. Yeah.
9. Balance the following redox reaction equation: 9A, B, or C?
A.
A. C plus H2O, CO2. SO2 plus H2O, oxidizing agent. Which one is the oxidizing agent?
How do I find out which one is the oxidizing agent?
Well, it's very easy. One has more oxygen, that's the oxidizing agent. So which one?
C.
Carbon has no oxygen in it, so it's not. It's not the
yeah, I'm sorry.
H2SO4 has 4 oxygen. Carbon has only then, and agent is only reactant part. The product are never, agents are never found in the product part. So the oxidizing agent is sulfuric acid. Okay. So that's how we deal with it. Very easy. Now, this carbon, what is the oxidation number of carbon here? We're gonna go through the whole thing.
Okay, you said that way too fast. Can you repeat it?
Sorry, you are right. This carbon, what is the oxidation number of carbon?
0.
Yes. And this oxidation number of carbon in carbon dioxide.
I have no idea, but someone said 4.
Someone said 4, good for them. What is the oxidation number of oxygen in any compound?
I'm sorry, one more time.
What is the oxidation number of oxygen in any compound?
Okay, sorry, Professor. Give me 1 second.
-2.
That's what you need to remember or memorize or have it in front of you when you take the exam.
No, I heard you. It's just really loud. I couldn't hear you very clearly, so I was just holding on a second.
Okay.
But I got you now.
So that's carbon has 4 plus oxidation number, yes? In carbon dioxide.
Carbon dioxide has what?
Carbon in carbon dioxide has 4 plus oxidation number.
Okay.
So this oxidation number is changing. So we have a tie line going from the carbon atom to carbon in carbon dioxide. You have that already, right?
Yeah.
Yeah. And what is the other, where is the other tie line going from which atom to which atom? We have 2 tie lines. Where is the other one going?
What do you mean?
Let's see. What do I mean? I'm going to share the screen now.
Okay.
So this is what called a tie line. Yes.
Yeah.
And 4 electrons are given away. So -4 electron. How do we know that? Because this is 0 here. This is +4 here. Got it?
Okay.
Now, which one is the other atom that is gaining or losing electrons?
H2SO4.
Which one is the other atom?
Oh, H2O.
H2O.
Or
Atom.
X2.
That's not changing anything. H2 is 1 plus here and 1 plus here. So hydrogen is not being changed.
SO2, right?
S.
Oh, just S. Okay.
The atom.
Okay.
So
oh,
we
just
like
1.
that.
Okay.
Okay, we do like that, right?
Yeah.
Now, this is H2SO4. This is 6 plus here. We can calculate it, but I'm sure you can do that too, right?
Can you show me?
Sure. H2SO4, what is the charge on H2SO4?
Negative.
0. There is no charge on H2SO4.
That's
the compound. So we write down Z equals 0.
Okay.
Now, what is the charge on, or what is the oxidation number of hydrogen in any compound?
One more time.
What is the oxidation number of hydrogen in any compound?
0.
Hydrogen is 1 plus and for oxygen is 2 negative. That's all. That's easy to remember, right?
So hydrogen is 1 plus, yeah.
Yeah, so 2 hydrogen is 2 plus.
Okay.
Write down 2 plus here. We don't know about sulfur, so we just write down S for sulfur.
Okay.
Now, 4 oxygen is how oxygen, what is the total oxidation number for 4 oxygen?
What is the total of, you talk too fast.
One oxygen is how many? What is the oxidation number of 1 oxygen?
Say that one more time.
What is the oxidation number of 1 oxygen, an oxygen atom in a compound?
I have no idea.
We just talked about it. Hydrogen is 1 plus and oxygen.
Yeah. You say oxygen.
Yes. Oxygen is 2 negative.
Yeah, but you. Okay.
And I have 4 of those, so that's how many total? 4 multiplied by 2 is 8 negative, yes?
Mm-hmm.
We write down like that, 8 negative equals 0. Now solve for sulfur.
How do you solve for that?
Well, this is a simple equation. You have you don't know sulfur. You just so you know how to solve this simple mathematical equation, right? No?
S or 5? S or 5?
S. This is sulfur. Sulfur. S for sulfur.
Okay, so 2 plus
2 plus S plus negative 8 equals 0.
that's -4.
No.
If you want to rewrite it into like a mathematical equation, you could do 2 plus x minus 8 equals 0 and solve for x.
Yeah, we don't care. You can write X or Y or whatever you want to write instead of S. If you don't like S, looks like 5 to you. Yeah.
Oh, is it -6 or
It's positive 6.
it's +6? Okay.
Okay, so we write down positive 6 over here. That's why it's positive 6 written down here. Okay.
Okay.
And what is the oxidation number of this sulfur here? Remember, oxygen is 2 negative. So what is the oxidation of sulfur here in SO2?
4.
Yeah, 4 positive. How many electrons are exchanged?
2.
2. And they are given up or taken?
Given.
Taken.
Taking from the others. Okay. Oh, okay.
Yes, because 6 plus minus 2 equals 4 plus, right?
Right. Okay.
And electron is a negative charge. That's what the problem with all of us is. We are accustomed to, if you add electron, you get you decrease the charge. Strange thing, but that's how it is, right? So now you say 2 electrons are, this one is going to need 2 electrons, this one is going to need 4 electrons, which is the common denominator.
I don't know. I can't even focus right now.
I know it has been a long day. It has been a long day, yes.
Yeah. Can you repeat your question one more time?
And then where it's going to end very soon. What is the common denominator here? 2 and 4.
Common denominator?
Yes.
2.
Okay, we're gonna call it 4 because then
Oh, common. Oh, yeah.
Okay, so that means we are gonna need 2 of these to make it 4. Okay.
Okay.
So 4 electrons are taken, and this is gonna give 4 electrons. So we don't need to do anything here.
Yeah.
Okay. So now, and if this is 2, then this must be 2. Yes, yes.
Yes.
So now we're gonna use the trial and error method to balance this equation.
Okay, but okay, so I have a question.
Yes.
Because okay, so on the product side, right? It's you put 2 in front of H2SO4, which means it will be, so then that means it'll be 8 oxygen. Like
Well,
if you,
we're not gonna concern about oxygen right now. We're just gonna concern about sulfur. You're right. That's the next step you are going to. You're right.
okay.
But you know, that's the before the step is just we write down 2 over here because 2 sulfur must be at least maybe 4, maybe 8. We don't know, but at least 2. So now you go to the next step. You're right. Now, how many hydrogen?
4.
So I want 4 hydrogen here, right?
Okay.
Okay. Now you count oxygen.
Okay.
Is usually the last one we count.
So there's 8 on the product side.
Yes.
And there's 2, 4, 6, 8. Would CO2 that means it's still 2 oxygen, right?
This is react product side. You already said 8 on the product side.
Oh yeah, products, yeah, 8. And then the other side's also 8, the reactant.
Done. All right, that's it.
That's a lot of work.
Oh yes, it is a lot of work, and it is a tedious work. It's just you have to be very, you have to be do it correctly, little all the multiplication and division. Otherwise, you can't do it.
Okay.
But you will be given the steps. Okay, now you folks finish this work. If you are already done, send it to me. If you are not done, finish it and send it to me before you do anything else. Yeah.
Perfect. We don't have to go over this problem because I think I got it, but just to clarify from what we said earlier, for 9, you want us to turn that into a molecular equation and then solve for it because you're given the net ionic. It's the one right under the one we just did.
That's right.
Okay.
All right, see you at 5:30.
I just had a
You have 2 more minutes, so if
question.
anybody has any questions, your time right now until 5:30.
I had a quick question. It's not
Yes.
about this assignment, but
That's fine.
on one of the assignment that's due tomorrow,
Good. That's a good time to ask about it.
there's no like submission thing for it.
There is assignment due tomorrow? Which assignment is that?
It
was the lab.
Let's find out if there is such a thing.
It's the KMNO for centralization. I think it's the lab.
Oh, it's the lab. Okay, let's see. Assignment. We look at that. Lab. KMNO4 due March 2. Well, if it says over here, there should be something that you should be able to do over here, no? It's published and everything.
Yeah, he's saying there's no submission.
Yeah.
Point 10, so there are more options. So here you should be able to do that there. Yeah.
No, he's saying there's no submission link to send in our work.
Yeah.
Okay, let's take care of that. Oh, I see. No submission. Shoot. Online. Thank you for that. Okay. Very nice. Appreciate it. Okay, there we go. Thank you. Oof. This thing is moving around. Okay, thank you. Bye-bye.
I think at this point, I'm glad about that kind of stuff.
Hey, Professor.
Yes.
I know you mentioned something about spectator ions on part B.
Yeah.
And I don't see any spectator ions written here. I'm just trying to make the molecular equation.
Can you show it to me what it is? Is that that would be easier for me then.
It's on your screen right now. It's 9 part B.
On my screen?
Yeah, the screen you were just showing.
There is the net ionic equation is given here. That's part B.
Yeah, but
you don't have to do anything. Just use the net ionic equation. There is nothing to do. You don't need a spectator ion, anything.
Okay.
Just use the net ionic equation and balance the net ionic equation. That way the spectator ions won't come in your way. That's nice, right?
Yeah, I guess that's true. Okay, but you were saying to make the molecular equation when inherent.
No, I thought I misunderstood you.
Oh, perfect. Okay, so then I think we're good then.
Yeah, I thought it was the other homework. The last.
Oh, good.
Yeah. Okay, bye. See you in an hour.
Adios, Professor.